VLSos here. This is a video lesson on frequency. What we're going to talk about is the frequency of a sinusoidal wave. And we're going to use the general equation y is equal to sine of bx. So this is the parent sine function that has been transformed by multiplying horizontal variable x by anything. When b is equal to 1, then we don't have to show the 1 times x. It would simply be sine of x. And that is the parent sine, the simplest sine function. The parent sine function has a period we could call p of 2 pi. And we'll sketch a graph of parent sine. Parent sine has a period of 2 pi, which we'll label here. Halfway is pi. Sine starts at the origin, heads up, reaches a maximum of 1 at pi over 2, intercepts the x-axis at pi, negative 1 at 3 pi over 2, and completes one complete wave at 2 pi. This graph of parent sine is the graph of the equation y is equal to sine of bx when b is 1. Thinking of this b as a transformation, it's a horizontal transformation because it affects x. When you multiply, you get a dilation. Depending on what you multiply, your dilation could compress or stretch. We're going to get a horizontal compression, or if we wish to perform horizontal compression by a factor of 2, then what kind of equation are we going to have? It's going to be in this form. And remember, transformations are counterintuitive. So if we want to compress, which means to shrink horizontal distances in this case by a factor of 2, or to have horizontal distances, then we need to multiply x. The equation y is equal to sine of 2x is going to be the parent sine compressed by a factor of 2. So in this case, b is equal to 2. What does that look like? Well, in our parent wave, we could imagine there being a point at this maximum. It's at the domain pi over 2, and it has a horizontal distance to this point of pi over 2. So to have that would mean that the maximum of the wave after it was transformed would be here, halfway to the vertical axis. This intercept at pi is going to move to pi over 2, half the distance. The place of 2 pi, which is the period of the wave, is also going to have and be located at pi. This minimum, half the distance, is here. So the entire wave is going to shrink, and these points each represents a horizontal distance that has been halved or compressed by a factor of 2. I can draw a sinusoidal wave to contain them, and I can see I'm going to draw more than one period and make it bold slightly to highlight it. This should look like, especially in comparison with the sine wave, this should look like the sine wave that has been squashed. Let's think about what happened to the period of the dilated sine wave. Sine, parent sine, completes one period in the space of 2 pi. after compressing it by a factor of 2, I can see that I have 2 complete periods. So the period, the space to complete just one, in this case, is pi. And there's a relationship between P, the period, and B, the horizontal compression factor. Period is the space it takes to go through one iteration of a cyclical function or a periodic function. The value B affects that, but we don't put P directly into the equation. We call the value B the frequency of the cyclical function. We call it frequency because we can think like this. Parent sine has a frequency of 1, a B value of 1. We could think, how frequently does one period happen in the space of 2 pi? It happens once. The frequency of this transformed equation is 2. We could think, how frequently does the sine, the wave, happen in the space of 2 pi? Twice. The relationship between period and frequency is this simple equation. Period is equal to 2 pi divided by b. And we can change this algebraically into other simple forms. If we multiply both sides by b, we also get the relationship period times frequency is equal to 2 pi. And of course, we could divide both sides by period to get another version of this equation. B is equal to 2 pi over period. Let's do one more example. If we're given the equation y is equal to sine of x over 2, then in this case, we can see that we have a b of 1/2. The frequency of this sine wave is 1/2. What's its period? We could substitute in the value 1/2 into any one of these equations and solve for p. Or we could think also, if the frequency is 1/2, then how frequent, how much of one wave do you get in the space of 2 pi? You're going to get half of the wave. So we could go to graphing that, approaching this with several different concepts now. The maximum and minimum is still going to be 1, -1. The sine wave is still going to start at the origin. But in the space of 2 pi, we're going to get 1/2 of the sine wave. Its frequency is 1/2. Or we could think of this as a horizontal dilation where we're stretching because we're dividing by 2. So we're doubling distances. It's counterintuitive. Dividing by 2 means to double horizontal distances. Any way you want to think about it, the graph is going to look like this. 1/2 of the wave in the space of 2 pi, which means that we would need another 2 pi of space to complete one wave at 4 pi. So we have a period of 4 pi, which we could have worked out with the b value in any one of these equations as well.